closed organ pipe. When one end of the organ pipe is closed and one end open, then only we call it closed organ pipe. You see, open end is always free for maximum displacement. Obviously, antinodes will be formed, and this closed end it doesn't have that liberty of vibration, so nodes are must at the closed end. One node that is must and one antinode, this is the minimum possibility, and that way you find the whole thing between one node and antinode. As you know, the distance between two successive nodes is lambda by 2, it is going to be lambda by 4 only. So, the total length here in this minimum possible case is equal to lambda by 4 L, and that means lambda 1, this is 4 L. Since the frequency is given by V upon lambda, this is going to be V upon 4 L. As in the case of open organ pipe, we know that the minimum frequency is known as tone, that is known as lowest frequency, that is known as fundamental frequency, and that is also known as first harmonic. Harmonic is always the integral multiple. Here in this case, this is the minimum possibility, and then all the other higher harmonics would be in terms of its multiple. So, this is fundamental tone, or sometimes it is also known as tone only and first harmonic. Now, it is very interesting if you consider the second higher possibility. That means you have to increase one node, but you know node and antinode will always increase in pair. So, this is the case now going to be possible is this way. This is node and one antinode. So, 3/4 or 3 segment quadrant you find over here, it is lambda by 4 3 times, and overall this, if you sum up, will find the length, entire length 3 lambda by 4, that means lambda becomes 4 L by 3. This is lambda 2 because the second possibility, and again the frequency is going to be V upon lambda 2, that way it becomes 3 V upon 4 L. N2, this becomes equal to 3 N1. Since it is higher than the previous one, this will now be termed as overtone. It is the first overtone. As it is 3 times the first harmonic, we will call it third harmonic. Third harmonic and first overtone. So, what is interesting here to be noted is that second harmonic is missing, and likewise if we proceed further, we will find the fourth harmonic will be missing. So, that way let us conclude that only the odd harmonics are available here. Odd means 1, 3, 5, 7, 9 and so on. So, what is the case going to be in this example is you go on writing N1, N2, N3, N4 and so on. N1, this is first harmonic, and tone over tone I would write here, this is tone. Then N2, this is third harmonic. It is going to be third harmonic and first overtone. N3 will be 2 into 3 minus 1, that means fifth harmonic, but this would be second overtone. Likewise here it is seventh harmonic and third overtone. Overtone, while deciding overtone, you just reduce from this serial one digit. If it is N4, you will call it third overtone. Suppose it is N11, then you are going to call it 10th overtone, and moreover this is going to be 21st harmonic. For deciding the harmonic, you multiply by this serial by 2. See, this is 11, then 2 into 11 minus 1. This is the way how we decide the harmonic, but for deciding the overtone you have to reduce 1. It is N4, then you call it third overtone. And some more things are interesting and rememberable is that here node and antinode are always equal in number, whereas in the case of open organ pipe we notice that the antinodes number is always greater, nodes number is less. Number of nodes there could tell you the number of harmonic, but here it is not the case. Here you have to be alert, N1, N2, N3. These will proceed in the usual way, but N2 means first overtone and third harmonic. We will call it third harmonic and first overtone. Similarly, if it is N6, then you are going to call it 11th harmonic and 5th overtone. This entire process will go on. For deciding harmonic, multiply by 2 and then reduce 1. And for deciding the number of overtones, simply from this serial number you have to reduce digit 1.